All right. Welcome to the B Attempt. This is Circ05 B Attempt. My name is Christian Williams. It's October 20th, 2021, literally seconds after recording that C attempt. The only real difference is this is similar to previous attempts. All we're doing is activating a different portion of the code that was in the C attempt by changing one thing in this case. And it's not going to change how it looks when you're looking at the Arduino board. It's honestly going to do the same thing as the C attempt, but what's happening in the program in the background is different, and this is basically doing things the hard way. So from what I understand, instead of letting the Arduino do a lot of the thinking and doing its thinking very fast, it's having to rely a little bit more on the integrated circuit. Basically, the best way I could think of describing it is this program makes our Arduino a little dumber, um, instead of doing things simply. So the program is, again, copy-paste, so I won't explain the integers or anything this time around. We still have our same outputs, everything. We still have our loop. However, we changed one value in this loop. I'll get it up closer to the cheater box there. You can see right here, we have changed that from update LEDs to update LEDs long. So this loop is now going to reference to a different portion in the program because we've changed that, what value we want it to change with that for statement. So this was the previous statement that we used, which was the update LEDs. And as you can see, with 3 lines of code, it's able to handle those 8 LEDs. The second part, which we're more interested in for this time, is the update LEDs long. So this sends an LED state to the chip in sequence, and so the shifting is done in the software specifically, so you can see what's happening instead of letting the shift happen more in the code. We were repeating this 8 times because we have 8 bits, 8 LEDs in this case, and we're using what's known as a bit mask. This basically sets the binary value for each LED. So this is how the integrated circuit and the Arduino know which LED is in the 2's place, or in the 4's place, or in the 8's place, that and so on. This is how it sets it. And so you can see here we have, if the bit is equivalent to 128, then our 8th bit is going to be the highest setting. And once it gets to that point, it has to restart because there is no 9th bit the way that we've set up this board, if that makes any sense. Each bit, for the purposes of this program, is an LED. And then it'll continue with the program. The rest is normal. There's a little bit more information, including a Wikipedia link that was included with this program. But zooming in very quick, you can see it's basically doing the 1, 2, 3. Well, actually, no, this is wrong. This is setting which place each LED is in. My apologies. So this is this 1. Whenever the binary value has a 1 in this place, the respective LED needs to turn on. So this bit mask right here is the one that links the first LED on the bottom row in the left, which I'll again show the board for comparison. This is what assigns it to the 1 value. And this same over here, this assigns that second LED to the 2 value, and then to the 4 value, and then to the 8 value, and so on and so forth. All right, so again, in practice, I'm going to transition here. We're going to restart my code since it was running in the background here. You can see it's doing exactly the same thing, but the Arduino is doing a lot more of the calculations instead of relying on the shift register to do it. So basically the C attempt, as far as I can understand, is the better of the 2 attempts in terms of compression and what it's doing and so on. But just like before, you can see it's counting up in binary, starting from 0 with our little integrated circuit. No fancy wiring has changed whatsoever. The only advantage of this B attempt is we get to see what's kind of happening internally in this chip, which is useful for me. But yep, that's really the only difference between the two. Still counting in binary. We're just using bit masks and so on to let the programming actually figure it out instead of letting the integrated circuit doing it. So that is it for the C and the B attempts. I'm going to play around with this and come up with something for the A attempt. Thanks.